This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. It's episode 740. This week, we're going to welcome Anthony Cox of Community Housing Partners, Energy Solutions Division. We're going to be talking about building science, weatherization, indoor air quality, and healthy housing. Before we get started, let's thank our sponsors. They're the reason we can continue doing the show. IAQ Radio Association sponsors are AIHA, the American Industrial Hygiene Association, at AIHA.org. IICRC, the Institute for Inspection, Cleaning, and Restoration Certification, at IICRC.org. The Restoration Industry Association, RIA, at restorationindustry.org. The Environmental Information Association, EIA, at EIA-USA.org. Actionable Insights at getinsights.org. IAQ Radio industry sponsors are Particles Plus at particlesplus.com. BioPlanet at byoplanet.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick at cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. I'm sorry to report that no one identified Hurricane Patricia in 2015 as the hurricane having the greatest wind speed ever recorded for a hurricane, which trivia-wise was actually 215 miles per hour. Here's today's IAQ Radio Trivia question. Who founded the organization known today as Community Housing Partners? Back to you, Joe.
Thank you, Cliff. Anthony Cox is a building science manager and lead trainer at Community Housing Partners in their Energy Solutions Division. He's got over 30 years of experience in weatherization. Since 1999, he's played a vital role in developing and delivering training programs internationally for the home performance industry. He's the creator of the widely recognized training tools like the House of Pressure and the Ham House, which we'll be looking at today, which are designed to illustrate building science principles effectively. I met Anthony at Joe Steebrook's summer camp probably 10 years ago now, maybe longer, and I've always enjoyed learning from and talking to him over the years. Anthony, welcome to IAQ Radio. We finally did it. We connected.
Yeah, thanks for having me, guys. I really appreciate and enjoy following the show. I always learn a lot, and just hope I can give back a little bit today, and hopefully have a good time.
Well, first, I wasn't that familiar with Community Housing Partners. I looked at the website. I learned a lot over the last week just trying to get ready for the show here. Tell our audience a little bit about the history of Community Housing Partners and what they do today. They're a bigger organization than I think most people realize.
So we started in 1975, and I actually started as kind of more of a emergency kind of home repair kind of thing. And actually the biggest thing we did was we did outhouses. We actually dug outhouses because a lot of the rural areas didn't have bathrooms still, and then eventually we got into doing called indoor plumbing and rehab, where it was more of actually building bathrooms and that kind of stuff. We would do like roll roofing and, on lower slope roofs and things like that. So it was a really just kind of a grassroots, program to begin with. Like I said, that was in 1975 there, and then 76. That's when the weatherization program started. When they had all the oil stuff back in the 70s, and then that's when the DOE developed the weatherization program. And CHP, at the time it was called Virginia Mountain Housing. We changed our name, around in the 90s, somewhere late 90s, but somewhere around there. But anyway, we got into the DOE program right off, with the weatherization, and that's really my background as far as CHP. I actually worked in as a community action program for 9 years before coming to CHP, with the weatherization program, and then, I did construction and stuff like that. But CHP mainly our main company does housing development. So we have about 400 employees, so we're a pretty large place, and we're spread between, I think, Baltimore and on down south. We were down in the Florida. I don't think we have really much going on there now, but we build, affordable housing. We rehab multifamily properties. We mostly do low-rise multifamily, well, although we do have a 20-story building there in Baltimore near John Hopkins Hospital, and we've built some net zero duplexes and things and stuff like that. So all of our stuff is really more, sustainability, energy efficiency, and always kind of on the edge of that and how to implement that into new affordable housing. Where I work is what we call the Energy Solutions Division, and we do weatherization there. And like I say, they've been doing that since the weatherization program started. I actually started in 1990, so I've been doing this 34, almost 35 years now. But So doing the weatherization program there has been a big part of my life, and I've really gotten to enjoy that. We do about 650, I think, weatherization jobs a year. So we're actually one of the largest weatherization providers probably in the country, probably, top 10 or 12 as far as size goes. In Virginia, we do, I think, almost 50%, 40% of the state, at least, I would say, like that. So, but we have,
What's going on there?
and then we have about 125 employees within the program there. And I specifically work with the training center, which does training for weatherization for home performance contractors, agencies across the country. We'll talk later. We've been working down in South America with a program called Weatherizers Without Borders, which has been a big pleasure to work with that. I mainly do training. I do consulting, problem solving, like as you'll see, develop these little training models, to help simplify things and make it visual and stuff like that. So it's certainly, I enjoy that. If you ask anybody, if you ask me a question, it's not going to be a 2-minute answer most of the time. I'll kind of,
No
I had to break it down for them,
hey,
but CHP is a great program. Weatherization DOE is a great program. We had National Weatherization Day was actually on Wednesday. It's October 30th. So, but just so weatherization is coming up, on 50 years. So, in a couple years. So, but it's been a good program to be a part of, and CHP as well.
I've been you sent some really great videos, and we'll look at some of those when we get a chance here. But the one was on the history of the weatherization program. It was about an hour long, but once I started watching it, I couldn't stop. I watched that son of a gun. I saw a lot of people I know in there, including you.
Yeah. Yeah, I was in there a little younger, but yeah,
And
I've been
that
there.
industry's kind of been, up and down depending on whether there was financing available or whether there
Sure.
was, a focus in that area or not. Right now, I'm assuming, I could be wrong, there's a whole lot of interest in weatherization. Is that accurate to say?
Yeah, I mean, this, what they call bill money is kind of the new money that's coming in. And like you say, I mean, over history, the money fluctuates, and you have to kind of ride the waves there a little bit. We had ARA funding, back in 2009 to 11, 12, somewhere around in there for a few years. And yeah, I mean, certainly there's a lot more interest in it, as far as like doing the work. Anytime more money is available, more people want to be, it's more noticeable, more people want to be involved. And sometimes, that grows, and sometimes it can kind of hurt things too if you kind of jump in things too fast. But hopefully we've learned, and some lessons, from the ARA period, where you're trying to drink from a fire hydrant kind of thing, and training a lot of new people and bringing in contractors and stuff. But I think that this can also be spread over a longer time frame. It's not just 2 or 3 years like the ARA funding was. It's recovery and investment funding. And
ARA
then,
was the American Recovery and
yeah,
Reinvestment. Okay. ACT, I
yeah,
think.
yeah. Yeah, that was around 2009, 10, somewhere around in that area, and weatherization ramped up a lot, and we had a lot of good things came out of that. We developed these standard work specifications and things and stuff, and so it's and our personal issue, I mean that case, the our training center. We use that to upfit our training center stuff. So that's been sustained, long term. So sometimes things kind of come and go, but we had to, CHP has a lot of foresight, and kind of, when we had the opportunity to do that, we could build things that be, lasting long term, and the training center, has been a big part of that and continues to be going forward. And
Now, let me ask you this. You sent me another video called Grandma's House, which
oh
is
yeah,
excellent. I had seen it once before, but I watched it again. It's only about 5 minutes long, and it essentially goes over the mistakes made early on
right.
in weatherization. You got a
Sure.
guy with the truck, and he's insulation, and then he adds air sealing on the side of the truck, and then he adds I
The
can't remember what
fan,
the next
the
one was, but
ventilation fan.
yeah, he does ventilation, and talk to us a little bit about
Sure.
what some of those early mistakes were and what kind of indoor air quality and other problems they led to.
Yeah, I would tell you, that, weatherization, like I say, early on, it's that videos called Filling the Gaps, but, in the 70s and stuff, they might have had $150, to do a house, and so it's more of just, store plastic on the windows, those kinds of things at the time. And then it got into more of insulation, but it wasn't really any attention to air sealing. We did a lot of windows and doors, which look pretty. I can measure a window down, to an eighth of an inch. We replaced a lot of windows, but it really just wasn't really saving any money. Made the house look good, probably made the house more valuable. Sometimes we call it, that was more beautification, not weatherization. So weatherization was more of learning how to air seal better, and a lot of times we would use literally, I mean, kind of when I came along, we maybe used 200 tubes of caulking on a job because we would
Wow.
caulk everything. We would caulk all the trim in the house, all baseboards, the ceiling, any outlets, anywhere air could come in. But what we didn't know was we really should be focusing not where the air is coming, well, into the house, but really where it's coming in from the outdoors, like in the attic and the crawl spaces and things. And the term bypasses is kind of ones that came out of that. And there's a fellow named Gotham Duck. He was like worked at Princeton University and did some research with early blower door and stuff, And so the blower door, helping us to find air leaks and stuff like that. But the other thing, as far as things we weren't doing, we weren't looking at heating system safety and things and stuff like that, moisture and things. But fortunately, for the most part, we weren't that good at air sealing house. Yeah, we used a lot of caulk. We put attic vents on, but we didn't do any air sealing in the attic. And so, I mean, we've had houses where we did an air leakage test or a blower door test, and the number might actually go up, after we had worked on the house because we let more air into the attic, but we didn't seal it to where it was coming, into the house. And things like that. So learning where to better air seal, learning that windows, the studies on those, they were saving very little, and the payback was a long time. I mean, not that windows are bad, it's just that on the scale of things, that wasn't really a top priority thing to focus on. And
Let
then
me,
as we got, go ahead.
well, go ahead. Go ahead. I want you to finish this. You got better.
Okay. Well, I was just going to say, as we got better at air sealing, thank goodness, like I say, up until that point, we hadn't been that great at it, but we learned about heating systems, combustion safety, just visual inspections of chimneys and heating systems, fossil fuel systems, and just making sure those things are safe. That's a big, cornerstone of weatherization. And yes, it's an energy program, but the big piece of that is health and safety, or do no harm is kind of one of the terms there. Is that we go in, we look at heating systems, we look at water, moisture, we look at lead, all those kinds of things. We keep all that in perspective now, and so we make sure we have safe operating heating systems. And early on, we didn't have a lot of money to replace heating systems. So I mean, I personally and some of my team, our director let us go through heating system training. I got my master's HVAC license, and I mean, I really learned a lot about heating systems, but just making a house more airtight. This house's system can affect, the indoor air quality by, with moisture, with, as you mentioned, as you saw in the grandma's house or anybody that can watch it. And then combustion safety, and just learning that and learning how to make a house not only efficient but mainly safe. A lot of times you make it safe first, comfortable, durable. You don't want the house to rot down. You don't want the smoke from the wood stove to come back into the house. But when you do those things to correct that, a lot of times you're getting, the energy efficiency benefits, from the same work. But yeah, we had, a lot of mistakes early on. But well, I went is learning, and like I say, thank goodness we weren't that great at air sealing. But as we've gotten better, we incorporate all those things now.
And it's become more important. Now, where I see that kind of adding complexity is in training people to do the right thing. Before, training someone to use a caulking gun and put up storm windows, that's not too tough. But
Yeah.
training someone to evaluate a whole house and determine what reactions there are to the actions you take has got to be a lot more difficult.
Right. Yeah. And like you say, that grandma's video there, the little 5-minute video is this, but we always start out with building science, and that's kind of where these little model houses that I use is called a ham house, heat, air, and moisture. You're trying to control the heat, air, and moisture in the building. You do that by air sealing, you do that by insulating, ventilation, all those kinds of things. And so, yeah, I mean, it is a lot to learn because, like I said, a lot of people just think it's a hammer and a caulk gun, and it's not. It really is. These people, these ladies and men that are working in the field, they are, building scientists, whether or not they have a title that says that, but they need to have that understanding of how the house is a system. We call it whole house weatherization because when I air seal a house, I might not be touching the water heater. But if I make the house tighter and maybe it's a dryer vent that's not connected, yeah, we want the dryer vent to vent outside, but that affects the tightness and the air pressures in the house and can affect like the venting of that water heater or something like that. So just learning all that, the basic building science, and then why they're doing the work and how it affects how the home operates.
Anthony, I've got a question. Or actually, I don't know if it's a comment or a question, but early on, storm windows were a big thing, and then they kind of backed off. But in my personal experience, I'm in the mountains of Pennsylvania here. It's cold as hell, and I put storm windows on my house, and they seem to help me a great deal in managing my electric bill. Okay.
Yeah.
Are you still doing storm windows as opposed to having
Um,
people replace their window, or is that
mm,
not
yeah.
common for some reason?
Right. In some areas, like you say, the colder areas, they may do some storm windows, and it's all, most all the programs have to run some kind of energy model, so how much is it going to save versus how much is to put in. So in some areas, northern places, yeah, it still might be cost effective to do some storm windows. If you got single pane windows, it's really just kind of that cost effectiveness kind of calculation. But a lot of it depends on your climate, and how many what call heating degree days, how much heat you have to put in your home and stuff. But all that is typically, ranked in some type of order. Like the energy modeling software will tell you, okay, if you do air sealing or insulation or like you say, storm windows or whatever, what is going to make the cut, and then in what priority, to do that. And usually, like a storm window would probably fall toward the bottom of the list, but ultimately, most of the programs use a savings to investment ratio of 1, meaning that the cost that it takes for the material and to install it's got to save at least that much money over the life of the measure. So if the storm window lasts 25 years, then the materials and the labor to put that in, it's got to at least pay that back over how long it lasts. So
I
yeah.
got you.
it's not that they don't work or can't work. They might not be as effective as air sealing or insulating or something like that. So,
Well, and the
but
other problem is you have to maintain and you have to remove them and put them back in and so on. And a
yeah,
lot of your customers, from what I've seen anyway in the videos, they may not have that ability. It's an older person living in,
yeah,
by themselves, and they're not going to be as good at putting in those storm windows and
no,
climbing a
no.
ladder and so on. So
Mhm.
that can be difficult. Um, as far as I just want to kind of re-emphasize the focus has gone away from the walls and more to the top and the bottom. Would that be accurate to say? Like
Yes,
attics and crawl spaces and
sure. Yeah.
basements, and then the top and the bottom are the first and most important thing in weatherization.
Yeah, and that all goes back to it's what's called stack effect, and that's it's not now heat goes to cold. People say, heat rises, but it's not really heat rises, it's hot air rises. And so if you have holes at the top, especially the top, because the pressures in the building, are greatest at the top and the bottom of the building. When you have a temperature difference outside, if it's 70 degrees inside and 10 degrees outside, and depending on how tall your building is, you'll have this pressure in the building. And if you have holes in the top of the building, then the air is going to leak out the top. And then along with that air goes heat, moisture, whatever. So a lot of times your home might be in the wintertime cold and dry because you've got all this heat, that's leaking out the top of the building, which means if it's going out of the top, it's going to pull air down in the bottom of the building, which in the wintertime is cold, dry air. And then that's why you'll see sometimes in the grandma's house video, they had a pot of water on the stove because the air leaks at the top of the building was taking all the heat and moisture with it. And grandma was having to have the pot of water on the wood stove to add moisture to the house. And it was leaving as soon as she was, as soon as it was evaporating into the air and the house was just cold and dry. So really the key is not trying to seal where air is maybe leaky coming out, on the walls and things and stuff because your greatest pressures are usually at the top and the bottom of the building. And if you can seal those areas, that's going to make the biggest difference, and sometimes you'll have air coming out, maybe a tub access or something like that. But the best place to seal it is underneath the house or like I say, in the attic. That's going to have the greatest effect because what would happen would be is we would seal a hole in the wall. We'd run our blower door test and then it would just come out somewhere else. But the problem really wasn't where it was coming out of the wall. It was where it was getting into the attic and then down to the wall and into the house. So if we sealed it in the attic first, then that really prevented a lot of us chasing leaks, is what we used to do. But now we've gotten, much better at sealing in those high priority areas.
Okay, Cliff, I want to make sure you get a chance to jump in if you want. If you had
Do you want to do the text question now? Can we do that?
yeah, go ahead. That's a good one.
Yeah, we had a text question, Anthony. How does water vapor get behind vinyl wallpaper, which has very low permeation rates in buildings like hotels?
Right. Well, obviously that would be more of probably a cooling climate where you're cooling down the building, and so the vinyl wallpaper is basically a vapor barrier, it's not going to let moisture go through. So if you're air conditioning the building and the moisture from the outside is wet's going to go to dry, and that's one of the big things, we talk about building science, hot goes to cold, wet goes to dry, high pressure to low pressure. So in this case, it could be just, you got more moisture outside and it's trying to work its way in and it gets to that vinyl wallpaper. It can't move through that paper anymore. And that wallpaper is cold. It's going to condense and sweat. It could be that it rains on the building. Maybe it's brick or something that absorb water and then the sun comes out and it wants to drive that vapor in. And if it can't move on through the wall and it hits that surface and it's below what we call dew point, then it will condense and it will just turn that wall into mush. You can stick your finger through it. So, but it depends on the time of the year, so that would be more of a summertime issue. But I mean, you can certainly have issues in the wintertime where things are going the other way. So,
But
yeah.
doesn't it also have the unit heaters that are in each one of these units have something to do with that as well? like a
Yeah.
hotel room or whatever. Each
Oh, well,
hotel room.
sure. Yeah. Well, I mean, like in a hotel room, you'd have these what they call package terminal units, what they
Right,
call
right.
PACs. They just go through, and you'll go into one of these. Yeah, I'm sure most of you been into a hotel room, and it's like 65 degrees or 60, and it's really cold. But part of it is those things maybe don't do a great job at removing moisture if they cut on and cut off. Any type of system that doesn't like the air conditioner. It's kind of one of your removal systems for moisture. If it doesn't run long enough, then it's not doing a good job removing moisture. So sometimes people will lower the thermostat to make it run more to help it remove more moisture, but in reality, they're making the temperature lower, which then increases the relative humidity. So it ends up kind of feeling like cold and clammy, because you're kind of fighting each other. So part of that has to do with the sizing of the equipment. Part of it probably has to do with the climate and the air leakage and the pressures, pulling the moisture in and out of the wall and stuff like that. So a lot of the answers you get in building science is it depends. It depends on
Right.
where, depends on the time of the year, depends
Right.
on which way the air is going, how strong the pressure is. And it's not always a cut and dry answer, and that's why you got to kind of use your visual and your senses, as well as diagnostic equipment to kind of evaluate. Now, a lot of the things, yeah, I mean, it's pretty. Once you kind of learn building science and stuff, you have a pretty good idea of what's going on. You just have to kind of verify, sometimes and confirm what's really happening, so to speak.
Anthony, why don't we do this? Let's put Grandma's house on for just a moment, if you would.
Okay.
I
Yeah.
think that helps illustrate some of the initial early problems with weatherization really well. And maybe you could skip through it a little bit and not spend the whole
Yeah.
5 minutes.
Sure.
But before we go to
Okay.
halftime, I think it would be a good thing to show.
Do you want me to let it play the audio and then just watch it for a
Nah,
minute
just
and
why
then
don't you
stop?
talk us through it? Because I think,
Okay. Whatever you want to do, we'll go that route.
well, they
Okay.
do a good job of having words up on the screen too. So,
Okay. I'll make sure that's on. Right. I'm going to turn the sound off, and then I'm going to share my screen here, and then I'll hit play, and then we can kind of just watch it go.
this is a great video to show people who may have questions about weatherization and
Right. And
how
this
it
is
affects the indoor environment. Go ahead, Anthony.
I'm going to say this is on YouTube, so you could probably just do Grandma's Hospitalization. I guess you'll have show notes and things and stuff like that. You can add this to. And so basically here, it's just talking, and they kind of talked in about like a children's stories kind of way they're explaining it, like Little Red Riding Hood, and just talking about how grandma, has to spend a lot of money to heat and cool her house, and it's just cold and dry and uncomfortable. And so Red, Little Red Riding Hood, is kind of help her grandma out. So
And they showed the boiling pot of water on there too that grandma had, and I have running in my home here in the winter because the relative humidity gets so low, you've got to add a little humidity.
yeah. Yeah. And so basically grandma, needs some insulation. So grandma calls a contractor, comes out now, and like I say, he doesn't really know this house's system or whole house weatherization concept. He's more of just, I'm an insulator, I do insulation, and so he goes out, he insulates. And after he's insulate now, you can see, I'll pause it there just for a second, that after he insulated, that they started getting moisture on the ceiling, and grandma thought she had a roof leak. But what had happened is once they insulated, yes, it made the house warmer, but it also made the attic colder. Whereas before there was warm, moist air getting into the attic, that roof where you now see some water there, it was warmer. In other words, it wasn't below dew point. Again, dew point is the kind of the temperature when you start having, condensation and things and stuff like that. So before, that attic was pretty warm. And you may have seen, and a lot of you probably have, especially in your area there, Joe, when you get snow, that you'll drive by a house and one house has snow on the roof and then one next to it has big spots melted. So, but anyway, going back to this, he insulated the attic. He didn't air seal. So the moisture from the pot of the water was still leaking into the attic. But now that the attic was colder, it was condensing on the roof. But she thought it was a roof leak. So you can see here, like I say, Big Mike's truck. So there's where he come in. The insulation, it's explaining that it made it colder and now created the moisture issues.
There you
This,
can see
this is a
what
little more
happens.
severe, right?
Yeah.
Yeah. So he has to come back, and do some air sealing. I'm playing the video at about time and a half speed, so it kind of moves through a little bit better. But the video it's about 4 minutes total there. So now he's basically pulls out the insulation and air sealing, meaning that you want to air seal before you insulate. So now, the I'll just pause it there for a second. Now that he's insulated and grandma still has her pot of water on the stove, that pot of water is now it's not leaking into the attic anymore. The moisture is now staying, in the house. And in this picture here where I paused it, this is maybe a single pane window. Again, one of those key terms, and you all know that is dew point on this show, a lot of the moisture stuff. If this single pane window, for instance, is below dew point and this is a surface that can't absorb water, it's just going to condense on the window. So basically, she couldn't see red anymore. When Red came over, she noticed that. And then as it goes on, uh, you'll also see that she started getting spots on her wall. And it says a little at a time, and then it got more and more and more. And basically that moisture is now absorbing, into the walls and has really caused some severe problems there. And then it's talking about, of course, if you got mold, then you have to do remediation and stuff. But they were just talking about insulating the wall there a little bit, that little clip right here. And this fellow right here, this is a big thing we do in weatherization is we insulate homes and existing houses. And we'll do dense pack insulation. And this person has a tube, it's hooked to a blowing machine. And they take that tube and they push it up the wall to the top of the wall. And it packs the insulation in the wall under pressure, and they call it dense pack. So not only does it help insulate, it helps air seal as well. But as far as moisture goes, insulating the wall is certainly going to increase the temperature of the wall, meaning that it would be above dew point, and not as likely to, have any moisture issues or less moisture issues anyway.
Anthony, I got a quick question
Air
for you.
sealed and insulated.
Dense
Yes.
packing. In the historical version they said that was ground up newspaper with boron, I believe it was.
Borax.
Borax added. Is that still the case today?
Yeah, as far as I know, it is. It has a fire retardant in it, and then there's cellulose, there's fiberglass. Those are probably the two most often used blown in insulation. But like I said, go ahead.
It was shocking. They showed him with a torch, and I think
Yeah.
it was a nickel on top of the cellulose, and the nickel melted, but the cellulose did not
Right.
catch on
With the
fire. That
fire
was
retardant.
fascinating to me.
Right. And in that video, I think he talks about a home that had actually that was on fire, but the part that had the cellulose insulation in the walls or the blown in dense pack, that it didn't burn, that part didn't burn, at
And
all.
in fact,
And
the
other parts of the
ceiling,
house.
when the ceiling burnt, the drywall dropped down and the insulation put out the fire. It was-
Yeah, that might have been part of it. I don't remember that part, but I can
yeah, I remember. I saw that last night. Go ahead. I'm
Yeah.
sorry. I didn't mean to
Oh,
interrupt.
it's okay. No, it's good stuff. I mean, it really is. And there are sometimes areas in the home where we can't get to physically to air seal, and we may have to use dense pack insulation, to get to some areas to pack it with the insulation.
How good of an air sealer is dense pack?
Well, I mean, it's not a perfect air seal. It's not going to prevent air leakage totally, but it certainly does a good job, in reducing it. So insulate, because a lot of times the older homes, they had lath and plaster or tongue and groove, those walls, leak a lot of air, and so insulating those walls could really cut down the air leakage, a lot. And some older homes now part of this is along with air sealing, but they might have what's called balloon frame walls, meaning that the walls were open in the attic and in the crawl space. You could take something and drop it down the exterior wall and it'd fall out in the crawl space, but so we'd have to seal it. We'd have to stuff something in the bottom of the wall, on the top of the wall, and then the dense pack, would fill that up to insulate. But it does a good job of air sealing. You've got to pack it under the correct amount of pressure. You don't want to just blow it in there lightly. You have to have your machine set up correctly and set it to correct pressure, to pack it properly, and so basically, I mean, not that you would do this, but we do little training walls, and you pack it in there and you can take off the drywall or whatever, and it's stays in there because it's packed in there, under pressure and stuff. So
Hmm.
yeah, it does a great job. Like I said, it's not going to totally air seal everything, but it's going to can make a huge difference, especially in a lot of older homes that has certain types of construction.
Okay, so Big Mike started out as an insulation guy, then he started doing air sealing.
Right.
He probably had to do a little mold remediation in between the two, but
Yeah,
go
yeah,
ahead.
yeah, yeah. They had to deal with that, right? And so, what happened here was, hey, we got kind of the moisture took care of, but let's put us an exhaust fan in just to make sure that any moisture vapor and stuff will exhaust out when you're cooking and things and stuff like that. But what Big Mike didn't understand is that Grandma also had a wood stove, and guess where the wood stove takes its combustion air from was from the home. And so basically now Grandma, the wood stove, and the exhaust fan are all competing for the same air, especially now that the house is a little more airtight. Whereas before, and without the exhaust fan, the wood stove had plenty of air. But with
I
that
can vouch
exhaust
for that
fan,
one. I had the same problem here, and we basically had to stop using the wood burner, although I wanted to anyway. But yeah, it became almost impossible to keep a good fire going.
yeah, yeah, and you can certainly have, air leaks, even a leaky home, and depending on if the chimney's on the inside of the house or the outside of the house, it affects how well things draft. But in this case, it was really the pressure being created by the negative pressure being created by the exhaust fan that was causing the issue because they were all competing for the same air. And in the video, it goes on to say that who's going to win. It says the big fan, always wins, right there in the text, right? So that
Yeah.
fan's going to get its air. So if it's exhausting 100 CFM of air, it's going to bring 100 CFM of air somewhere. And one of my good friends is John Tooley, and he taught me a lot, and I continue to always learn from him every time I'm with him. But basically that air is going to come in the biggest, largest, first available hole that it has. So if it's got this nice, we've sealed up other stuff. Now the chimney might be the easiest place for air to come back in. And it doesn't necessarily mean you don't want combustion appliances in your home. It just means that you need to understand where they're getting their air from, how other things are affecting it. Maybe the air should come from the outdoors instead of from the indoors. Some equipment you can modify. Some equipment that you buy now, especially like gas furnaces and things and stuff, even tankless water heaters, they all have outdoor air. And in this case, they just put like a little. They simulated that by just putting an outdoor air feed into the uh, wood stove here. They also added a vent they showed right there. It was basically an intake vent or a makeup air. And now, of course, if you got code now, if you have an exhaust fan that has more than 400 CFM of exhaust, like a kitchen exhaust, it has to have makeup air or supposed to, so that when just like a kind of like a commercial restaurant would have, it's got to have air to come back in. As far as ventilating the home goes, you might want to look at what we call ERV or an HRV, which basically brings air in and exhausts air out. So it keeps basically a neutral or slightly positive pressure in the building. In this case, in this video here, that exhaust fan was probably making a huge negative pressure in the building, or at least enough pressure to backdraft that wood stove, and so again, because they were all fighting for that air. And so now the wood stove can get its air from the outside. The exhaust fan can pull its air through the makeup air. And there are ways to do that. This is just a good, this video is just a good example, of the building science, how the house is a system or whole house weatherization, that kind of stuff, and
And
and,
Big
and if
Mike's now
somebody,
doing combustion testing too,
oh
huh?
yeah, 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 he does it all now. He's educated, and grandma survived, and he got educated and learned a lot. Hopefully, grandma didn't have to pay too much as he tried to rot her house down and backdraft her a few times there. But learning from all that, and if somebody asks me what I do, my wife used to always say that don't ask him what he does, because I'll tell you like I'm telling you now. And I've had people on the airplane, ask me what I do. And so now I've just got to the point. I just show them this video. I show them this video. And then the next question always out of their mouth is, I have this going on in my house,
Yep.
And then I've had somebody on the other side of me, I'd be in the middle seat, we'd be 30,000 feet in the air doing a training on weatherization, So But this video is great. It came from some folks in Alaska, the Building Science Network. It was a PowerPoint that they had during the ARA. This is one of the good things that came out of ARA. I mean, a lot of good things came out of ARA, but this is one of the ones in particular that basically I knew of this presentation, this PowerPoint presentation. DOE was looking for video to make. I said, you need grandma's house. And so I connected them with the people that had the information, and they made this, and it turned out really well. Like I say, it's short, it's concise. You can jump off into pretty much any building science topic with this video. And
Now we know the backstory.
yeah, it's great. Yeah.
Grayson, let's stop for a minute. We got to stop and thank our sponsors at halftime. We're in a little over halftime, but I always enjoy chatting with Anthony. Go ahead, Grayson. Our association sponsors are AIHA, Healthy Workplaces, A Healthier World, AIHA.org. The Environmental Information Association, EIA's multidisciplinary membership collects, generates, and disseminates information concerning environmental and occupational health hazards in the built environment at EIA-USA.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry, IICRC.org. The Restoration Industry Association, the oldest and largest nonprofit professional trade association dedicated to providing leadership and promoting best practices through advocacy, standards, and professional qualifications for the restoration industry at restorationindustry.org. Actionable insights, no more mistakes, no more missed line items in your Xactimate estimates at getinsights.org. Industry sponsors are Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. BioPlanet at byoplanet.com, improving human, animal, and environmental health with electrostatic spray technology and advanced chemistries at byoplanet.com. All right, we're back for the second half of our interview with Anthony Cox. Anthony, let's go to the ham house real quick. I just want to show people what type of training tools you've developed for your courses, and also before we go there, how many different courses do you teach at the Energy Solutions Division of Community Housing Partners?
I don't know, off the top of my head, probably 15 to 20 main, but I'd say main ones. They focus around BPI and stuff, so it's probably 10 or so. But we can pretty much teach about any type of thing: building science, HVAC. We've been teaching more classes on heat pumps. I do a lot of classes on heating system fundamentals. We do ASHRAE, ventilation courses, of course, RIT, which is installer classes, crew leaders, energy auditors, and some of the classes we do in Spanish now as well. So we have two training centers, actually. We have one in Christiansburg, Virginia, and then we have one in Baltimore. And it was actually a sheet metal training shop, and we purchased that and kind of retrofit that into a weatherization program. So, we teach a lot of courses, and if it's something that you're looking for, it's building science, HVAC related, we can probably either do it or know someone else that does. So,
all right, very good. Well, let's take a look at the ham house. Just give people an idea of what you do and what it can show in a smaller version of a real home.
Yeah. Okay. I'm going to share that now. I'll do the same thing. I'll just keep the audio off.
And HAM, of course, stands for heat, air, and moisture. Those are the three things we're really focused on here. Go ahead, Anthony.
Right. Okay. So you can see the house here. It does have 3 floors. Like I say, the heat, air, moisture house. And so I've had homes or little houses where I've done like stack effect simulation, sometimes with a little pipe. My friend Dick Kornbluth, he called it the stackulator, I think is what he called, but showing heat movement and stuff. But I wanted one to also do moisture and show condensation and stuff. So this little house here, it's about a foot by foot square and probably maybe 4 foot tall, something like that. In the bottom down there, I've got a couple little tea lights that will heat the house up. I have usually I have 2 or 3 little temperature, humidity sensors in there that also show, well, they show temperature, relative humidity, and dew point. So dew point being the temperature again that things will start to have condensation forming. And you can see the temperature in there is about 145 degrees. So grandma, she really likes it hot. Also, but in a room it might be 70 degrees. So you might have about a 70-degree temperature difference. So it might be like having the house at like 70 in the winter and 0 outside. So you're kind of creating that temperature difference there is mainly what you're doing with that. And so we talk about the heat. So I'm just going to kind of skip forward here a little bit to where the heat is. And so we use like a little thermal camera. This is one that's built into well, it adds onto your phone. And so in the house here, I have a little attic, and you can take it and you can do a little infrared scan. Of course, we're doing it from the outside of the building. So we're basically looking for where heat is escaping. And you can see the framing. Basically, that might be an attic access where the insulation is missing and some things like that. Let me go down here and show you where the wall is here.
Yeah,
So
I
let's look
thought
at
that
the
wall
wall.
section was very
Yes.
interesting.
So let's look at the walls right here. So here's a little clip of looking at the walls. And so you can look at the wall. Now, again, we're looking at it from the outside. So anything that's warm, would be heat leaking out, and anything that's dark would be not. So that might be anywhere that's dark would show maybe that there is some insulated areas. So you're looking at one wall area section there, and then he's going to move down here to the bottom, and you can see another section here. So you can see that part right there that's really bright. That probably indicates that there's no insulation. Now, you always say when you're doing thermal stuff, you say it appears. You don't say, well, there's no insulation there. You want to do some type of other confirmation, either visually or some other diagnostic tool. And then in this example here, you can see where he took the wall off, and you can see that there was insulation in part, but not in the other part. So you can,
I can't, it doesn't seem like you would think you'd see a bigger difference between no insulation and the fiberglass, where you can see a pretty big difference between the foam,
right.
but I didn't
So,
see.
so the one there's fun. Now, see the foam also is not in there. It's got gaps and things and stuff like that.
Okay.
And then the one cavity was completely, uninsulated. So it was you could see. So of course this turned around, because when the wall goes on, the part that had the missing insulation is now on the left side. So
Gotcha.
but of course, if you was in the wintertime and you were on the inside of the house, it would look just the opposite. You'd be looking for darker spots because it's colder outside than it is. So part of it depends on where you're at. Most time you're inside the building. It depends on what time of year. You have to be cautious of if what time of day, if it's sun in the building, and what to call solar loading and stuff. But I would recommend, folks go through a thermal infrared class, whether it be for just building science. They have 2 or 3 day classes just for building science related, and they have level 1 and things and stuff. But just having a camera and knowing how to use it and what it's telling you or may be telling you, like I say, it appears to be, and just understanding, that it could be electrical, could be moisture, could be heat loss, all those kinds of things. So
Anthony,
that, yeah.
I got a question for you here because I had one of those little Seek thermal camera deals that you could use real easily and quickly, but in the video on the history of weatherization, they showed how the first cameras were like you had to have, I don't know, liquid nitrogen or something to
Yeah,
cool it off,
yeah, yeah.
and it was crazy. Now we're to the point where you can attach a little camera to your phone and do thermal imaging. But I'm wondering, in the field, do people use these phone cameras? Have they gotten that good?
Yeah, yeah. The best thing about those is that they're easy to keep with you. I mean, I keep mine. I don't have it in my pocket right now, but most of the time I do.
Yeah.
Most of the time I have it in my pocket and I can carry it right with me. It's with me. It's I can pull it out. It gives me because you're looking for like big stuff. You're looking for like anomalies. Yeah, sometimes you're not super concerned about the exact temperature as you are just the temperature, your differences and stuff. And a
Okay.
lot of times, like you say, you're verifying it with something else. But yeah, I mean, the first camera we had when I started was at least when I went to come to CHP is around 1999. We bought a used camera. It was $17,000. It was black and white. It had a whole line of pixels out, and I had like a little pocket recorder that I had to put on the side. And it was not good, at all. And I first started using it, I recorded everything. I go through the house and then I quickly learned not to do that because it was on a tape and you had to go back through the video. But so then I learned to just kind of walk through the house, look at things, and then go back and record things. You also, as far as like energy stuff, you want to look at the infrared before you do an air leakage test or a blower door, because then you're looking for what we call conduction losses, maybe where you got missing insulation. And then when you run the blower door, to find air leaks and you're using the thermal camera at the same time, you can see where those air leaks are coming in. It looks like fingers are a little feathered, kind of where air's leaking around things. So, and because in the old days, we spent more time walking around with our hand feeling for air, but now I can use that thermal camera. I can look across the room and see where air's or on the ceiling, places I can't even reach. And know that these might be things going on, or chases or soffits, or just kind of hitting framing areas that you might not would kind of feel with your hand. So the thermal camera is one of the best tools and has came a long way to where you can just put it in your pocket. And
It seems like that's probably maybe one of the most, if not the most important tool for people doing weatherization.
yeah, I put that along, that and the blower door, the blower door, thermal camera, those are probably the two biggest tools. You can measure air leakage, the heat loss, and of course we're looking at things like with moisture meters and things and stuff like that. But blower door, thermal cameras, probably the two biggest tools. And I like smoke pencils, little fog pencils, to help see where the air's going. So I'm kind of a gadget guy. Anybody that knows me that's on this call, knows that I'm kind of Mr. Gadget. One of my mentors, he says, well, some things are made to buy and some things are made to use, and so sometimes you get things maybe that don't quite work out, but the thermal camera certainly is obviously one of those that is a great tool.
Let's focus a little on indoor air quality and weatherization. I'm wondering, what are some of the biggest things you've learned over the years about how weatherization affects indoor air quality?
Well, I mean, the biggest thing is going back to the house's system. As you tighten up a house, you certainly can affect indoor air quality. You don't want to just go in and don't take that house's system in consideration. If you just go in and start air sealing, just like happened at grandma's house, that they started having moisture problems and combustion safety problems. And so you can certainly make things go wrong pretty fast as far as indoor air quality goes, especially with those types of things with moisture and carbon monoxide, combustion safety are really the two big ones. But I mean, you have things like radon and things. And we don't install radon systems in weatherization, but we certainly can do some things to kind of prevent. We put the barriers down in the crawl spaces and things and stuff like that. So, um, but certainly those things. Of course, we have to be cautious of lead and if we've got work, we got to follow lead safe protocols. If we run into friable asbestos and stuff, so sometimes we might have to. Have someone else come in, or maybe it might have to be deferred. We got some funding to help with that some now, but certainly moisture, carbon monoxide are probably the two biggest ones, and just kind of understanding
Do
that how
you?
you tighten the house up, it may affect things.
I went to a training program once for weatherization, and they depressurized the building with a blower door. And my first thought was, wow, you're sucking everything out of those walls into that house. And there could be lead paint, there could be, mouse feces, there could be any nut cockroach allergen, dog and cat, you name it.
Yeah,
Do you
yeah.
guys talk about that at all? Do you worry about that at all?
Well, I mean, certainly when you're running the blower door, you're kind of flushing things out of the building. And I know sometimes even when they would build new buildings, that they would run a blower door to kind of run it for like an hour or so to flush things out. But certainly with an existing building, you have to, be cautious of those things and like I say, be wary of, and particularly things like friable asbestos or vermiculite or some of those things that could, get into the air, versus things that might be in the wall, not so much, but just from, other things that,
Carpeting, etc.
yeah,
Now,
yeah. I mean, it's a certain, you don't want to take those things lightly, but for sure, you keep that in mind.
what about running it in a positive, positively pressurizing home? Does that make it harder for you to evaluate the air leakage?
Well, the only thing when you blow air into the building versus suck it out, it's typically a little bit leakier, and sometimes we'll do that on commercial buildings where we do a depressurize and a pressurize because when you're blowing air in, you're blowing open like vent like dampers on kitchen, bathroom, dryer, exhaust fans. So all those are going to now leak air versus when you're depressurizing. But other times we might use it just for diagnosing, not specifically for measuring the air, but you can certainly do it. Just know that it's going to be a little bit leakier. I mean, you can certainly go around and tape off those vents when we do commercial buildings. We tape off like fresh air venting and stuff like that, so that when we're testing the building, not the mechanical stuff. But
And there's a good comment from that the backdraft dampers may blow open as well.
yeah, that's what I meant. Yeah. So if you're
Okay.
pressurizing the building, like on your bathrooms, and so I don't know. They say like on commercial buildings, they say maybe like 10% it's going to leak more, something like that. But it's certainly going to leak more. But basically, yeah, where air is going out, now you can use your smoke pencil. And let's say there's a hole, or maybe you're trying to investigate and you take a smoke pencil, and now the smoke will actually go, toward the hole and then try to get out of the building. So versus when you're depressurizing, sometimes it's coming in, if you're trying to use smoke or fog, it's kind of hard to tell where the air's coming in. So there's certainly good reasons to do that, and like you say, you might want to just prevent that. You do that, prevent stuff from coming in for sure.
Now, we had a mutual friend, Kevin Kennedy, on the show a few weeks back, and he seemed to think that weatherization folks are in a good position to help with efforts promoting healthier housing. So the whole healthy homes program that Kevin's been working on, when he was at Children's Mercy, he continues to work on. Other people think maybe the HVAC folks might be better positioned to do this type of work. I'm wondering, what are your thoughts on that? Maybe
Um,
restoration people.
well, I'd say it's everybody should be aware of it. It might not be everybody's job, but if you run into it, you need to be able to recognize things. It's kind of like putting another set of goggles on, and I've been through Kevin's class. I through that with him and Joe Medash, and it's a great class. And like I said, weatherization does a lot of health and safety stuff, but that definitely certainly digs into it a lot more, because you can, and moisture and things and stuff, and just the things that are going on in the house to recognize the safety issues and stuff like that. Weatherization, we have depends on what state you're in, but they can typically about 15% of your budget can be for health and safety and things like that. And some states have more, if they've requested more, but which, it can kind of go toward some of those items. And some things, as far as weatherization goes, DOE dollars can be used for some measures, but not certain things. The other times we have funding sources, at CHP, I was talking to some of our guys when I told them I was going to be on this kind of like CHP. We have like 26 different funding sources
Wow.
that we can pull from. Now, some of it can do certain things, and we have utility funding, we have LIHEAP funding, we have the uh, deferral, repair funding, those kinds of things. And just so they are some things that we can do as far as weatherization goes. Some things it's beyond what we can do, and maybe we can recommend to someone else to do it. But I'd say certainly it would be good for anybody in those industries, anybody that's working on a house. If you're making changes to a house, if you're having being able to recognize those issues. And like I say, and if you're not able to deal with them, maybe, learn more about it, and maybe connect folks with people that do. And just things like this show and other things, you learn who some of these people are in the industry that may be in their wheelhouse for certain things. And that's one of the great things that weatherization, but really just building science industry in general, is just that all my experience over the years is if people have been willing to share, help each other out, recommend folks, and just and one of the things I really like it, but besides helping people is probably the biggest thing I like for sure in weatherization. But I'm always getting to learn stuff, new stuff, and
Yeah.
the more I can learn, and like maybe it's something that I don't end up doing personally, but I think I should know about, like you say, these health and safety things. And if you don't, you can certainly go through it. They got healthy homes, healthy housing principles. BPI has that. I was talking with Kevin. We were working with a lady, I believe her name's Karen Brenner. She's in Pittsburgh, but they're doing a weatherization training center, a clean energy training center, and they'll do weatherization training, but maybe do some health and healthy homes training there as well. So that'd be right in your backyard, Joe. So,
Absolutely. Yeah.
but yeah, I certainly see that connection. There's been Weatherization Plus, so there have been some weatherization programs that have focused a lot more on health and safety. They had certain funding for those things that can
Do
make
the
a whole.
guys in the weatherization world, do they learn about integrated pest management, things like that, just as because some of what you do actually would help with that,
Oh,
air
sure.
seal.
Yeah, one of my friends, his name is Chris Clay. He's out in Washington State. He works at a train. He did a presentation. It's about pest sealing and air sealing. It's kind of when you're air sealing, you do things where that pests can't penetrate it. It's impermeable to pests. So the things that when we air seal in attics and of course things we do like in the attic, we don't want the work that we do to get destroyed. So that might be doing things to prevent pests and rodents and things from getting in. And you were talking about the dense pack wall insulation. I had all my stories start out with I had a friend, but I had a friend, and this it wasn't a weatherization job, but the lady was she had ladybugs, lots and lots of ladybugs, but the walls weren't insulated, and so they were dense packing the walls with with the tree with the cellulose. She was talking about it had the borax in it and stuff, and it really. It was a pest problem, but they also got the air sealing and insulation benefits, out of it. And like I say, a lot of times you do things that help with health and safety also helps on the energy and comfort side, as well.
We're kind of running low on time. I don't know if you could stick around for a minute, but you know,
Yeah.
you're also doing weatherization work, your company at least, and I think you've been there yourself in South America. And I'm wondering if you could comment quickly on some of the uh, differences you see as far as what can be done, what actually can be done in some of these more rural and less developed areas.
Yeah, I mean, certainly the housing stock is a lot different, and the housing, is not as well developed or built, and a lot of times it's families just collecting materials, typically masonry, enough to build a building to start out, and then as a one of these terms I learned in Alaska, it's a Goodyear house, meaning that when you have a good year, you add on, right? Or you a family member, you add on. And so, but they would, be masonry, they may have a tin roof, a dirt floor, and Argentina is one of the biggest places we work. That's kind of my friend Nick Maggio. He came to DOE around 2013, learning about weatherization. He knew about it in the States, got connected with us, and we've been down there. We've done training for them, but just an example would be maybe the tin roof. It's first of all, it's got a lot of leaks, a lot of water. The house might have one window in it, so it has poor ventilation. For one instance, they had well, it's pretty common. A lot of gas leaks. They had like a gas stove. It's just really just hooked up to a bottle of gas sitting in the kitchen floor. But they would just turn it on long enough to cook because it leaked. The bottle gas would leak, when they turned it on. But it was
Wow.
just putting on at that time, it was like a washer or something. And electrical, sometimes electrical, you may have one panel that serves several houses. So if your power goes out, you got to go up the street to turn the power on. But
Fascinating.
man, it would get hotter in the summertime inside. I mean, it'd be hot outside, but with the tin roof and the radiant heat and all, it would make it hotter, so hot inside that they had to go outside to be cooler than inside. So, they certainly have done good, with air sealing and insulating and things stuff. I have a short little video clip. It's probably about a minute and 30 seconds. If you have time to show it, if not, I won't.
Let's
But
do it. Go ahead.
let me
And
just
then,
bring
then
that
we'll
up.
see if Cliff has any final questions after we show this video.
Okay, let me bring this up here. I'll do my share screen wherever it went. Oh,
It's
here we go.
on. You already are. I can see it.
Oh, okay, good. Okay, let me hit play. I want to have the audio with this one. So, yeah,
Okay.
the audio should be on.
Catalina García, pertenezco al pueblo
Oh,
central.
wait a second. Let me go back.
The audio's on, but I'm going to have a hard time understanding it if it's in Spanish.
Well, it's going to have it's going to have text on there.
Okay.
The which is the one I want. I think it's this one right here. Yeah, let's see. Yeah,
Very interesting. And this is in Argentina?
yes.
And right now it's probably changing seasons in Argentina. They're
Oh,
going
yeah.
from winter to spring.
Right, exactly.
Grisel. Yo vivo en el barrio La Arenal en plan federalismo en Casa 22. Necesitaba hacer arreglos en mi vivienda. Cuando vinieron ellos tenía filtración de agua por las paredes, por el techo, tenía muchas goteras, pérdida de gas. Ellos pusieron una serie de aparatos donde midieron las filtraciones de aire. Le
Yeah, that
pusieron
really
una
gives
de
you a good
vidrio, taparon
visualization of how they're built.
la que tenía.
Yeah,
La verdad
yeah,
que
that's what I want to show.
pensamos que iba a durar más tiempo, algo que lo vengo acarreando hace un montón de años
And is
y
this your team down there?
solucionaron en un día.
No,
Poder decir hoy llueve y duermo tranquila porque no
we set up
se la
training centers and help train folks, and then they would
hacen.
train community folks in the community.
Toda la onda y toda la voluntad.
Gotcha.
Solucionaron un problema que era re importante para mí y para la salud de mis hijos, que lo hicieron con muchas ganas y mucho respeto. Decirle a la gente
Wow.
que cuando vea que dice Fobis, que confíen en que van a volver y van a hacer lo que prometen.
That blower door, Anthony, was it? I can't imagine you got a very good number on that one. I saw a big hole up above it.
Yeah, it's interesting when we took blower doors down there too, because when you go through the government, they want to charge money coming in. So that was always an interesting aspect of it. But a lot of that, you used to ask about who was doing the work there, but that's people from Argentina. It was really a grassroots thing. It started out in Nick coming up to the U.S. and then working with some local communities there, and then kind of getting the community involved, doing work, and then one community starts doing, hey, what are you doing over there in your community? We want to do that in our community. So it kind of has grown from there. We had one of the mayors come up from Bariloche, which is down in Andes Mountains, area. It's kind of cold. That gets cold in Argentina. So we went down there going in August. It's I'll go through the airport in Atlanta. It's 95 degrees. I get to Bariloche in Argentina, and it's 20 degrees and snowing. So I had to do a change of clothes there. But certainly there's a lot to be done. And Nick, he's such a great inspiration, down there, because basically, we've had weatherization here for almost 50 years, and he's starting that from nothing. The people don't know what weatherization is, but a lot of it, and you'll see it's and as I know, it's as much health and safety and durability and stuff. But it also, the energy efficiency and comfort all builds on that. So those homes, they might fix the roof leaks. They put up a ceiling, put up at least some insulation, to make the house, where it's a little more they may even put, a window in and things, because it's, the one, I don't know the exact story, but there was a little girl there, and she loved to play soccer, but she had asthma so bad that she couldn't play. And, the house just had a lot of moisture issues. It wasn't well ventilated and things and stuff. And so at the end, I think she was feeling better, and was able to play her soccer, her football again. So just those kinds of stories. And a lot of the workforce is women, so it's a lot of women in the workforce there. So that's great to see. And, it's great. I had a 30-second clip of one of the workers if you wanted to see that. But
well, before we go, why don't you put that on without the sound? And I want Cliff to get a chance to ask any final questions or.
Great. Okay.
Cliff?
Yeah, thanks, Joe. We had one question in the chat that I think is going to be a pretty simple answer. So, well, let's let this go because it's short, and then
No, we are not Martians.
Lo más lindo del programa de mi trabajo.
Yeah, we'll just leave the sound up there. So basically, that was one of the ladies. She had to walk to get her water every day. She didn't have running water in the house or nothing. So
Wow.
just putting water in the house was a big deal. And this lady, I believe, got her home weatherized, and now she's one of the people that work on the crew. And she's just another inspiration just to see how getting out and helping people and learn about the stuff that we do. It's good stuff.
Excellent. Cliff,
Yeah, hang on, I had it. Let's.
I think it was another question on
Yeah, there was one. No, it was about the moisture barrier. I think it's going to be a short answer, but I'm going to let Tony answer.
Yeah, here we go. For wet buildings where there is a 90% relative humidity, does Anthony think moisture can be driven through the vinyl wallpaper?
No, I mean vinyl wallpaper is it's basically a visqueen plastic. It basically is a vapor. The low permeance of it's not going to go through the wallpaper, right? It's
Now they
because
are making some today that have some permeability, correct? I mean, they actually put holes.
they have what they call smart. I think they have smart vapor retarders where they can kind of I guess open up vapor-wise depending on. I haven't dealt with those, but I've heard of those called smart. I mean, in our climate where I'm at in Virginia, we got 4 seasons here. We got moisture outside in the summertime, inside in the wintertime, and so we really, as far as vapor barrier, we don't put a vapor barrier in the wall. You want the water vapor to be able to move through both all times of the year. So if you're in a extreme cold climate or something, you might could still do a vapor barrier in the wall, but for the most part, you know, uh, it's not something that you would typically do. And like I said, there are some that can change, between vapor open and closed, or depending on. I haven't experienced with those yet.
Anthony, before we go, can you just talk a little bit about that other house that you have? You have the Ham House, and what was the other one called?
Oh, the House of Pressure.
The
Yeah.
House of Pressure. So that was pretty sweet too.
Yeah.
And maybe we could just get a quick picture of it. And while you're doing
Yeah.
that, is there anything we missed that you'd like to add, or any other thoughts that you'd like to make sure we get out before we go?
I would just say, you learn about building science, and you can always keep learning and just, you know, um, just educate people about what you've learned. And, as I get older, which I measure this in decades now, how long is, being a good mentor to folks too, and just, be keeping those things, the whole house is a system in mind, and how all those things interact, because, you want to do things to help make the home better, but you want to do it safely as well as, cost effectively and stuff. But,
Gotcha.
but I'm always, I'm sure you'll have my contact or people. I mean, I don't mind. I enjoy talking to people, and, if they're new or experienced or whatever, and if I don't know the answer, I'll try to find someone else that
And
does.
this is the House of Pressure right here.
Yeah, I'm gonna turn the sound off
You
on
might
this.
be getting a call from one of our audience here. He said he's got one that he's ready to get rid of. So
Well, I don't know. It depends on, what you're using it for, and
he's pretty close to
how.
you too. I don't know if you know Danny or not, but
Oh yeah. Oh, I know Danny.
oh
Yeah.
yeah, good man. We got to get him on
Yeah.
one of these days too. Anthony,
Yeah.
thank you so much for joining us. We
Yeah.
appreciate it. Always a pleasure chatting with you. Hopefully I'll
Yeah.
see you at the next summer camp. We both missed it this year, but next year hopefully we'll both be back. And I want to just again thank you. Oh, the other thing I wanted to mention, you were talking about, how much you've enjoyed this industry. That's one of the things I noticed in the history of weatherization. And we'll put a link to that one up also. In that it's an hour long document. It's basically a documentary. But what I noticed is everybody in that documentary said one of their most important reasons for doing what they do is because it helps people, and the people were so appreciative when they do the work. And I want to say thank you for what you do. And I know a lot of people out there are living in safer and more energy efficient homes because of the work you've done over the years. So thanks from us too.
Hey, I really appreciate it. Thanks for having me on, guys. Certainly enjoy following the show, and always learn a lot when I'm on the other side of this. So
All
Thank you.
right. Well, this is Radio Joe Hughes saying thanks to this week's guest, Anthony Cox from Community Housing Partners, Energy Solutions Division. We'll be back again next Friday at noon. I also want to thank Grayson Gone Fishing Fisher, our engineer, Cliff the Z-Man Zlotnick, most importantly, our loyal audience and our sponsors. We'll be back next Friday at noon with the next episode of IAQ Radio Plus. I know that good-looking guy in that video there. Have a great day,
All
everyone.
right. Yeah.
For IAQ Radio, I'm Spike Reel saying thanks for listening.